Okay, here's lesson 3, and, or, union, and intersections. So we've got these two sets of numbers. We've got set A, which are natural numbers less than 20 divisible by 7. And we have set B, which are natural numbers less than 20 that are divisible by 2. So pause the video, try and write down what you think these sets are. You might have to look to the first page in your notes package and just review what natural numbers are. And after you've paused it, you should have got that the natural numbers less than 20 that are divisible by 7 are going to be 7 and 14. And then set B is the natural numbers less than 20 that are divisible by 2. So divisible by 2, you've got 2, 4, 6, 8, 10, 12, 14, 16, and 18. So again, we don't include 20 because 20 is equal to 20, not less than 20. And we don't include 0 because it's not divisible by 2. And here we go. So we've got these two sets, and we're going to create a Venn diagram to represent the relationship between these sets. So one thing to check is there any numbers that are common between the two sets? Okay, and it appears that 14 and 14 is the only number that's common between the two sets. So we're going to draw set B, and we're going to, set B and set A. And the only number that's common between the two is going to be 14. Set A also has 7. That is not in set B. So set B, you've got 2, 4, 6, 8, 10, 12, not 14 because it's already in that intersection there, 14, 16, and 18. All right. So we've drawn both sets, okay? And another thing that we need to do is to create that they're subsets of the universal set of natural numbers less than 20. So the universal set, we're going to include, you've got 1, 3, 5, 7's in there, so 9 is the next one, 10's in there, 11, 12 is in there, 13, 14's in there, 15, we've got 17 and 19. So this is the universal set. Using appropriate notation, list a set of whole numbers less than 20 that are divisible by 7. So A is equal to 7 and 14, and close it off with the squiggly brackets. Divisible by 2, set B is equal to these elements. So you've got 2, 4, 6, 8, 10, 12, 14, 16, and 18. All right. Now, which numbers are divisible by 7 and 2? 7 and 2. So this is going to be A is the intersection with B. So, and the only one that occurs is 14. 7 or 2, you're going to get A with a union with set B. So set A, union, set B. So 7 or 2, you've got 2, 4, 6, 7, 8, 10, 12, 14, 16, and 18. So we're going to just make note here that and, whoops, if I could spell correctly, let's try that again, and is going to be the intersect, and if we shade in this part, or implies that it could be either of them. And we're going to use this symbol, and that's the union between the two. So in this case, you've got this section, and that section. So everything. So the intersection of set A and B is called the A intersect B and is denoted by this symbol. and it's a set of elements that are members of both sets. The union of set A and B is set called A union B, and it's denoted, can't talk or can't spell, by this symbol. So A union B. Okay, it's a set of elements that are members of either of them. So here's another example. So again, I'd encourage you to pause the video, try it, and then check back in a second. So we've got set E, set L, and set O, and we're going to create a Venn diagram to display this relationship. Now you'll note that E has a number of elements that are the same. All right, so we've got E, L, and O, and then we've also got L and O that have common things as well. And a very important thing is that all of the elements of set O are part of set L, which will be very interesting here. So we've got a couple things here. So let's start with set O. And because O is a subset of set L, we are going to have set O inside set L. So set O has got 1, 3, and 5, and because it's a subset, it's also included in L. So the things that are unique to set L, we've already got 1, we've got 3, and we've got 5. So we've got to include 0. But 0 is also part of set E, so that's going to go in the middle. 2 is part of both sets as well, set L and set E, so that's going to go in the intersection. 4 is also common between the two, as well as 6. And the only number that we haven't dealt with here is going to be 8, and that's unique to set E. So write the relationship between sets O and L using proper notation. So O is a subset of L. Everything that's in O also belongs to L. And we're going to create the intersection. So the intersection means that it's the overlap. So what's the overlap between E and L? Well, E with the intersection with set L is equal to 0, 2, 4, and 6. And the last one is going to be the union of set E and set L. An important thing to note, do not write the same element more than once in a set. Okay? So E union L is equal to, and this is going to be all the numbers that are present. So 0, 1, 2, 3, 4, 5, 6, and 8. That's all of them. So consider these sets A, B, and C, where U, the universal set, is equal to the natural numbers less than 20. So you have to remember the universal set. And then we have these three sets, A, B, and C, that have some specific requirements. So list the elements of each set. So set A is going to be natural numbers less than 20 that are divisible by 3. So you've got yourself 3, 6, 9, 12, 15, and 18. And set B is natural numbers less than 20 that are divisible by 5. So 5, 10, and 15. We do not include 20. And set C, which is going to be 6, 12, and 18. Now the universal set, anything that's not included, you're going to have to remember to include those in your diagram. All right, so set A and set B. Let's examine these numbers and figure out, is there anything that's common between the two? Is there a subset? Anything unique that we need to figure out here? All right, so if I'm looking at A and C immediately here, 6 and 6 are in both sets, 12 and 12, and 18 and 18. which means that C is a subset of A. So if we're doing our diagram, you're going to have set C is a subset of set A. All right, and we are also going to have some commonality here that 5, oops, not 5, we've got 15 is common between A and B. So there is an intersection, and the number that's in both is 15. So 6, 12, and 18, which leaves us with 3, 9, and 18. And then for set B, we haven't dealt with 5 and 10. Now we do have to include the universal set, so we still have 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Again, we don't include 20 because it's not equal to 20, it's just less than 20. All right, so let's list the elements of the following sets. All right, so we've got A intersecting with set B, and the only number there that intersects is 15. Now the union of A and B is going to be everything that's included between A and B. So we've got 3, 5, 6, 9, 10, 12, 15, and 18. All right, we're going to have to dip back into our set notation. We've got the complement of A and, the complement of A intersecting with B. And in this case, we've got 5 and 10. All right, and we've got B intersecting with C, and that, my friends, is an empty set. There's nothing that's intersecting B and C. All right, the A with the union with C, well, because C is a subset of A, it's just the same as set A. So 3, 6, 9, 12, 15, and 18. And then we've got A intersecting with C, and that's 6, 12, and 18. Because it's a subset, it's just going to be that subset. All right, in each of the Venn diagrams, shade the regions representing the given set and indicate the shaded region using proper set notation. So the intersection of the two sets, A and B, is that, and that's A and an upside down U and B. And the union of the two sets is going to be everything. So A union B. And the complement of A is everything that's not in set A. So if you are highlighting this, it's going to be everything outside here, as well as B. And that is complement of A. So consider the following two sets. Again, pause the video, try them, and see what you get in a second here. So we've got set A, natural numbers less than 20 divisible by 3, and natural numbers less than 20 that are divisible by 5. In each of these Venn diagrams, I want you to shade the region representing the given set. So that's the thing that's written under, or what you're told to shade, and list the elements of the set and determine the number of elements in each set. So the first one we're doing here is shading set A. So set A is going to be all of those. And what's included there is 3, 6, 9, 12, 15, and 18. And how many numbers are there? There's 1, 2, 3, 4, 5, 6 elements in total. Shade set B. So that's that. That means we've got 5, 10, and 15. And we have 3 elements. Shade the complement of A. We just did this one the previous page, but it's going to be everything outside as well as this part of set B. So the complement of A, we get ourselves 1, 2, 4, 5, 7, 8, 10, 11, 13. There's a lot here. 14, 16. Am I going to fit them all in? 17 and 19. Should have written smaller. And if you count that up, there's 13 numbers there. All right, the complement of set B is going to be the outside, because it's still part of the universal set, and this part of A. You don't include that center 15 number because it's still part of set B, so the complement 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, and 19. All right, if you count those up, there's 16 numbers in the complement of B. All right, shade the intersection of A and B. After writing all those numbers, this one is a lot quicker. There's only one element. That's the intersection of A and B. And the union of A and B is going to be everything that's in A and B. So what do we got? 3, 5, 6, 9, 10, 12, 15, and 18. And there are 8 elements in the union of A and B. Again, here I would say pause the video, try these, and then check back in a second. So shade the complement of A and B. So the complement of A and B. So what we got here is going to be this part right here. Because 5 and 10 are part of the universal set, but they're the only parts of B that are going to be included in the complement of A. So we get 5 and 10. So there's 2 elements in the complement of A and the intersection of B. So shade set A with the union of the complement of B. So the complement of B, we've got to be everything here. It's part of the universal set. And we get that. All right. And 15 is included in this one. 1, 2, 3, 4. 2, 3, 4. 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So there's 17 elements included there. Shade the complement of set A and the complement of set B. Well, that's going to be everything outside the circles. So the stuff that's included in the universal set, but isn't part of set A and set B. If you count that up, there's 11 elements there. All right, so we also have the complement of A and the union complement of B. All right, so let's think about the complement of A. Well, the complement of A is going to be the universal set and set B. Okay, and the complement of B is going to be, again, the universal set numbers that are outside the circles and set A. So we leave out 15. All right. And there's a whole schwack load of numbers here. Be easier just to say not 15, hey? But here we go. Going into the second line. All right, and you count those up, there's 18 elements. All right, shade set A and B. The complement of A and B. Well, if you think about this in opposites, A and B, what's A and B? A and B is 15. All right? Interesting. So the complement of 15 is going to be everything else. So get rid of that. The complement of it is going to be everything that isn't 15. And here we go again. 1, 2, 3, 4. Oops, 6, 7, 9, 10, 11, 12. Skip 15, get 16, 17, 18, and 19. So there are 18 elements. Hey, that looks pretty familiar to our last one here. Samesies. Okay, so what you can note is A and B, so the complement of A and B is equal to the complement of A and the union of the complement of B. All right, let's do shade set A with the union B, and we're doing the complement of it. All right, so what's A? If we just figure out A union B, which would be that? Or which numbers would be that? Well, it's A with the union B is going to be everything there. Well, the complement of it is going to be all these numbers, which are outside of the circles. Okay, so we don't end up wanting the stuff inside the circles, we want the stuff outside. So we get ourselves 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. All right, and how many elements are there? There's 11. And if you're also looking, those look the same. So we can also note that A and the union of B, so the complement of A union B is equal to the complement of A and the complement of B. Use the Venn diagram to list the elements of the following sets. All right, so set P is going to be all that. So 1, 2, 8, 9, and 10. What do we got next? Set Q is going to be all those. So 1, 7, 10, and 29. And now we're going to get into a little bit trickier, so P and Q. So P and Q are the things that are in both. So 1 and 10. P with the union of Q is going to be everything that's inside the circles. So 1, 2, 7, 8, 9, 10, and 29. Okay, the complement of P. So the complement of P is going to be everything that's in the universal set as well as the stuff that's hanging out in set Q. So we've got 7, 29, 11, and 16. So if we put those kind of in ascending order, we've got 7, 11, 16, and 29. All right, complement of Q. This is kind of the opposite argument. So we've got the things that are in the universal set as well as the stuff that's in set P. So the universal set and the stuff that's in set P, we get 2, 8, 9, 11, and 16. All right. So the complement of P and the complement of Q. Complement of P and the complement of Q. All right, so if we do the complement of P, that's going to be the stuff that's in the universal set, as well as the stuff that's in Q. And if we do the complement of Q, we get the stuff that's in the universal set and the stuff that's in P. All right, which stuff's been shaded twice? Well, the only numbers that are shaded twice are 11 and 16. All right, the complement of P and the union of complement of Q. All right, so what's the complement of P? Well, the complement of P, we've got everything that's here. Okay, and that stuff. And then the complement of Q, if I choose a different highlighter, we also get the stuff that's in the universal set, but we get the stuff that's in P. Okay, so the only numbers we're not including are 10 and 1. So 2, 7, 8, 9, 11, 16, and 29. All right, what else we got? All right, P and the union of Q, but the complement. All right, so let's think, well, what's P and Q? The union of P and Q is going to be all of those things. Well, what's the complement? What's left? And the only numbers that are left are 11 and 16. So I know it can be confusing because sometimes I'm shading stuff just to think about what it originally is. So then the unshaded stuff is what I need to write down. And sometimes I'm shading stuff to see which things get shaded twice. So it's not, this is kind of how I think through it. I would encourage you to maybe come up with your own little way of, are you highlighting stuff to figure out what the original thing is, and then you're figuring out the opposite. But it is useful to kind of think through each scenario here. Okay, so the last one we've got are P and Q, but the complement of P and Q. So what I'm going to do is I'm going to shade what P and Q are, or is, and then what's unshaded is the thing that's the complement of it. So P and Q are 10 and 1. So in this case, because I want the complement of it, that means I'm going to write down all the numbers that haven't been shaded. So in this case, 2, 7, 8, 9, 11, 16, and 29. Which two pairs of sets are identical? So look through and figure out which ones are identical. And in this case, you're getting, grab another highlighter here, the complement of P and the complement of Q. So this one, 11 and 16, is identical to that one. So P, complement of P, complement of Q, and oops. All right. And what's the other one that's identical? So let's get another color highlighter here. Sure. This one is identical to that one. Okay, Venn diagrams can also be used to represent the number of elements in each set and not the individual elements. The diagram displays the number of students who are members of Students' Council. So you've got the S, Student Council, and the number of students who are on the yearbook committee. All right. So these aren't, in previous examples, those are the actual elements of the set, but this is indicating how many students there are. So how many students are on the Students' Council? Well, there's 12 plus the 3 that are on both. So there's 15. How many are on both? That's the intersection. And how many are on the yearbook committee but not the Students' Council? So that's 7. How many are on Students' Council or yearbook committee? Well, we got 12 kids that are just on Students' Council. We got the 3 that are on both. And we've got the 7 that are just on the yearbook committee. So in total, there's 22 kids. In a homeroom of 20 students, 15 take math, 12 take social, and 10 take math and social. Show this information in a Venn diagram. How many students take neither math nor social? This one's a little bit tricky. So there's 20 kids in total. So it's tempting to just go, well, there's 15 in math, there's 12 in social, and then there's 10. But if you think about this, 12 plus 10 plus 15 gives you how many kids? And that's 37. Well, we don't have 37 kids. We've got 20 kids. So what you actually got to do here is start with the thing that are in both. So the 10 that are taking math and social. So 10 goes there. Now in total there's 12, but if 10 have already been accounted for, that means that there's just 2 left over here. And same thing for math. Now there's 15 that take math, but 10 have already been accounted for. So there's 5 that are there. So if we count up the number of kids that are in this Venn diagram, we've got 2 plus 10 plus 5, which is 17 students that are accounted for. That means that there are 3 kids that aren't in either of those subjects. All right, last page here. In a survey of 400 households, 285 had personal video recorders, and 320 had multifunction printers. 63 households did not have PVRs or MFPs. All right, so let's figure out something here. So we've got the PVRs, got the MFPs, and we also have some other information here. Okay, so let's start with 63 households did not have PVRs or MFPs. So 63 are just hanging out. All right. Okay. We aren't told how many have both, but what we can do is we can put X in the middle. Okay. So we can put X in the middle, and we got 63 on our Venn diagram. Write an expression for the number of households who have a PVR and not an MFP. Okay, so we got 400 households. And we're going to subtract the 320 that have an MFP. And we're also going to subtract the 63 that don't have anything. That leaves us with 17, if you calculate it. And we also have the second part here. Write an expression for the number of households who have an MFP and not a PVR. So there, again, start with the number of households, 400. We're going to subtract the 285, which is the PVR. We're also going to subtract the 63 that have neither, and we get ourselves 52. So that means that we can plug these in, that we've got 52, and we've got 17 here. Okie dokie. Now our final step is to figure out who's in the intersection here. So we've got ourselves 17 plus X, which is the intersection, plus 52 plus 63 has to equal 400. Our total things here, so this plus, let's get a different highlighter. So this plus this plus this plus this has to equal 400. And if you do a little algebra, you get 132 plus x equals 400, which means that x is 268 that are going to have both. So the next step here is some practice. The answers are included at the end. Remember, you need to go through and just make sure you know what these terms are: sets, subsets, unions, intersections.